So next time we have class, which is Thursday for y'all, Friday for the other kids that might be watching this video, we'll have an opportunity to show how well you did with Chapter 8. No phones. Calculator's fine. And I have some if you need it. After you leave, or once you're getting done on our next day of class, I will give you 2 pages worth of notes. The first one is Trig A. The second one is Trig B. Trig A will be a video on Schoology to please watch to get the chapter started. Trig B will be for our remote day on Monday. Sound like a deal? We're good? And just a reminder, if you just click any of those, you can always print them off or just copy on a separate sheet of paper, or you can go buy the book from the Bare Necessities. Okay, kind of your choice. And let's see, anybody here? So Emily, just so you can write this down, you have 8A through F. That'll be a quiz, so kind of keep that in mind. And then I don't think there was anything else. So we'll get that once you're ready, okay? I'd say let's try and get it done by spring break.
Is that later than 2 weeks ago?
Yes.
In class?
Yes.
Okay. I can probably come after school.
Let's see, today and Thursday don't work after school because I have to run the basketball stuff.
Okay.
And that doesn't help you because you're not here any other days, but we'll figure it out. Are you off any periods?
5th and 8th.
You're always welcome to come in here 5th. I have an Algebra 1 class. So I would subject you to freshmen. I'm sorry. Or 8th period. I'm right next door in my office, and there's no freshmen usually.
Okay.
So if either of those work for you as well. But please don't feel the pressure to have it done. Just, you know the chat sections to look at, and then we'll be good, okay?
Thank you.
Perfect. And then spring break is sometime in March, so that's a while away, so if you needed to take that much time. Because I know there's some teachers going, this has to be done yesterday, and you're like, and I'm sorry for that, teacher.
Okay.
All right, so does that make sense? Trig A and Trig B will be coming out to you as in a packet. Next time we have class, we will have a test next time. But I would like to take a look at K. And what kind of questions did you come across on K that I can help you with? Yes?
25.
I'm sorry?
25.
25. And we have to remember we might have extraneous solutions, which is a solution that you get at the end, and if you plug it back into the original equation, it doesn't work. They're a little sneaky that way sometimes. I want to get rid of that exponent, so I'm going to raise each side to the 3/2 power. Now, because I'm raising it to the 3/2, that means this side's going to have a plus minus with it. Okay, so that just becomes x plus 2. We can drop the parentheses because we don't need that. So I'm going to go square root of 4, 2, and then 2 times 2 times 2, which is 8. And a reminder, it is that plus or minus. Because it was that, this would have been square root, which means that plus and minus has to be part of the answer. So that means we're going to have 2 answers. It's possible both answers work. It's possible they both don't work. It's possible that one works and the other doesn't, but we'll figure it out in a second. From here, I'm going to subtract 2. So I get negative 2 plus 8, which is 6. And negative 2 minus 8, which is negative 10. And then I want to double check if they work. So I'm going to take 6, plug it in. I get 6 plus 2 is 8. The third root of 8 is 2. 2 squared is 4. This one works. Did you follow what I just did? Or was I standing in the way? Yes, you were standing in the way. We saw this shiny thing called your scalp. All right, next one. I have negative 10. Now the big thing to note here, this is grouped. Agreed? So whatever this comes out to stays grouped, which is good. So I get negative 10 plus 2 is negative 8. The third root of negative 8 is negative 2. It's still grouped. Negative 2 quantity squared is 4. So both solutions work. That A-okay, my friends? What else did you see on, yeah?
On like the bottom part about the calculator, like 33 and 31.
Oh, okay. So we're going to use the graphing calculator. So I'm going to jump onto Desmos. And Desmos is totally fine to use. I have Chromebooks back there that we can jump onto, or if you have your own. Oh, she's not here today, my friend.
Thank you.
You're welcome. So if it asks to use a graphing calculator, yes, you're more than welcome to use the TI graphing calculators. But I think that Desmos is a nicer friend, especially when we're graphing. And so I'm going to set each side as two equations. So the left side will be y equals, and the right side will be y equals, so we can graph them. So first equation, I'm going to get y equals, and then you have to find square root, which is down on the keypad, down here. Square root of 70 minus 2x. And then outside of that, I have minus 10. Okay? And then the other one, I have y equals 21. Okay, now I can't see both. Let me change this to projector mode so it's a little darker. So y equals 21 is kind of, we're going to fade out a little bit. And look at this. So we're looking to see where the red and the blue lines intersect each other. And they look like they're starting to get close. But my goodness, we're at negative 290. Holy cow. Let's even go even further. Oh, it did intersect. Okay, it does look like it intersect because the red was below the blue and then it went above it. So I'm going to kind of zoom in, see if I can find it. Oh, right there. So it looks like my answer is negative 445.5. You only want the x component because the original problem did not have x and y. Yeah.
Will we read this on our test today?
I have to look. I don't know. I don't recall something like this where you have to go find it in Never Never Land.
Because then if so, would we be able to use Desmos?
Yes. Yeah. And we got those Chrome bad boys back there that are as old as all of you. But they should work. Or if you have your own computer, you can use Desmos on your own computer as well. So if I'm wandering around, I would only want to see Desmos on a computer screen. I wouldn't want to see Google. Make sense? And I'm not going to be hovering you over Hawks, don't worry. Just kind of. I'm just kidding. With that known, then number 33, we're going to do the same way. Number 33, I'm going to cancel this, I'm going to cancel this. Again, I'm going to have each side be equal to y, so I'm going to go y equals, parentheses, 3.5x plus 1, and then I'm going to raise that. And I need to put this in parentheses. I'm going to raise it to the 2 divided by 5, so that's the 2 fifths power. Oops. So there's my first one. And my graph is going to be off a little bit right now, but we'll go to it. I'm going to let the other side equal y. Let's see, 6.4 x plus 0.7 raised to the, use parentheses, 2 divided by 7. And my friends, if you get stuck on Desmos, you're like, I just can't make this plug in, I can help you. I mean, nothing in the math standards is, do they plug into Desmos correctly? It doesn't say that. So if you need me to help you on Desmos because you get stuck on it because it's different. But hey, look at that one. We have 2 fancy-dancy looking lines. Kind of pretty. So I just want the x value there, so negative 19.48. And then somewhere in here, let's see if I can find it. Ooh, they kind of kiss each other. Ooh, take a look. What can you tell me about those purple and green when I zoom in? Yeah, and that's the hard thing sometimes to see when you look at it going, yeah, but it kind of looks like they cross. When I look at this, it does look like it does somehow do it, but this actually comes up and rides along this green really close, so you might have to zoom in. So this right here was our only solution to this problem. Okay, so if we had solved this traditionally, which I would not give something this ugly to try and solve, it probably would come up with two answers. One of them would be extraneous, but you'd come up with negative 1.948. Again, I don't need the y component because my original problem on the paper does not have a y equals. Okay, that's a pretty graph. Oh, purple and green, gotta love it. All right, does that help you out on the Desmos graphing ones? The reason I don't like doing these on the graphing calculator is you have to start adjusting the windows. You zoom out and zoom in. This is a big screen. Obviously, this is a huge screen because it's projected. But when you're looking at a little tiny graphing calculator screen and it's all done by the same color, maybe you have the one that does the colors. Sometimes it's hard to see the crossings. Anything else off of that homework you would like to take a look at? Feel okay? Okay, so my friends, I'm untied. Sorry. Exposed y'all to my germs. Don't worry, you've been exposed to germs your entire life. All right, I would like to take a look at 8L. 8L. So if you have it, get it out. If you don't have it, maybe go over to somebody who has it, take a picture with your phone so you can take a look at it. 8L, my friends, I am not going to make do. This will not be an assignment that you have to complete. Okay, but I would like to make sure that you know and understand how to do each of the problems. So if you need a picture of 8L, maybe you can take a picture of it of your neighbors, which I just saw take place up front. Appreciate you sharing. And I'm just looking at numbers 1 through 15 right now. Is there anything off of 1 through 15 you would like a little extra guidance on? Anything from that very first page? Take a good, honest look at it. Down at the bottom, they want to know if they're inverses of each other. Do you feel comfortable plugging one into the other and getting X out? Yeah.
Can you do like any of, I don't care which one, any of the like G of H of X?
G of H of, which, number 12?
9 to 12.
9 through 12? Pick one. You pick. 10? Like it. It says okay. Perform the indicated operation, include the substitution step, leave in simplest form. State the domain using interval form, interval notation. So this is number 10. Okay, so this is what we want to do. So what I'm going to do is I'm going to write down what g at x is, which is x squared minus 1. And I'm going to write down j at x. And j at x is x minus 3. As these both sit, kind of important to realize that the domain of each of these, any number I plug in, I'm going to get something out. I wouldn't get an undefined term, which is great. Okay? We have no restrictions on this. Our answer might have restrictions, but as of right now, I don't have to keep a restriction in mind to move on. Okay, so what this means is I'm going to take j at x, which is this, and I'm going to plug it in for x. So j at x is going to be, it's going to be originally x squared minus 1, but I'm going to plug x minus 3 in. This is going to be x minus 3 times x minus 3 minus 1. Which gives me x to the third, minus 3x minus 3x is minus 6x. Negative 3 times negative 3 is positive 9. Positive 9 minus 1 is positive 8. Do you feel comfortable with the arithmetic I just did? Taking a look at that, I don't have any denominators with an x in it. I don't have any radicals. The nice thing is my two domains up here were this, so that means the domain of this is also going to be unrestricted. But you have to make sure you double check. Because it is possible that if you had unrestricted and unrestricted, that it might restrict at the end. And that usually takes place when you have a radical sign or x's in the denominator, or a radical sign with x's in the denominator. Does that help you out? Cool. Yeah. 8. H, g at x. H, g at x. Okay, they tell us that h at x is equal to root 9x plus 9. That's all underneath the radical. And g at x is equal to x squared minus 1. Okay. So I want to think about, I have a radical, so my domain is going to be kind of restricted up here. So we need to figure out where would this start making it become negative. And so you could go 9x plus 9 equals 0. So 9x equals negative 9, x equals negative 1. So I'm going to have a square bracket from negative 1. That would give me a 0. Square root of 0 is 0 to infinity. Okay? So I do indeed have a restricted domain on the top. We good? Yeah.
What does that mean?
If I plug, say, like negative 2 in, that would give me a negative under the square root, which would then refer to it being an imaginary number. I want them to stay as real numbers.
So everything from negative 1 to infinity is restricted.
Yeah, I could plug it. I could plug negative 1 in, 0 and 1, 2, 3, 4, 5, 6, 7, 8, whatever. Anything equal to or greater than negative 1 is what I can use. Anything less than negative 1 is a no-no. So if I plugged in negative 2 or negative 3 or negative 4 or negative 5, not going to work. Okay, it would give me an imaginary answer. G at x, being it's just x squared, is not restricted. This is negative to positive infinity. Okay, so let's see if I can make this work. I am plugging something that is not restricted into something that's restricted. Okay, so hang on. I'm just going to show the math that's going to take place. So if I do h g at x, I'm going to take g at x, which is this, and I'm going to plug that in right there. So I'm going to get square root 9 parentheses x squared minus 1 plus 9, which is going to be square root 9x squared minus 9 plus 9, which is going to give me square root 9x squared, which comes out to 3x. Okay? So that's the answer. Okay, but now, let's pretend, and I use the gluten-free reference often. Does everyone understand the whole gluten-free thing? Is there anyone's like, I have no idea what this gluten-free thing is? I'm using gluten-free for a reason. Let's say I have 2 recipes. One of my recipes is gluten-free. So this one's gluten-free. It's restricted. This recipe is not gluten-free. Does that make sense so far? So the top is gluten-free, the bottom is not. I'm going to take something that is not gluten-free and plug it into the recipe that is gluten-free. Does my recipe become gluten-free then? No. It's got gluten in it. So let's say as a thickening agent when you're making, say, gravy, you might add some sort of white flour. White flour is a gluten agent. Okay? Does that make sense? So let's say the gravy pack that I was using said it's gluten-free, as long as you use cornstarch as your thickening agent. If you use cornstarch, it's still gluten-free. Oh shoot, I'm in my cabinet, I don't have cornstarch, but I have flour. Flour is a thickening agent. I add the thickening agent to my gravy. That gravy is no longer gluten-free. Agreed? Okay, so this is my gluten. This is not. I'm taking something that is not and plugging it into gluten. That means that this here will not be gluten-free. That's my domain. Okay? Yeah.
So for 9, wow,
So if I went the other way, so I have one GH at X, then I will have my restriction. Okay, and this is how. If I were to take H at X and plug it into G at X, so I had GH at X. H at X is my gluten-free. I have a recipe that says it's gluten-free unless I plug flour in. If I want to keep that recipe gluten-free, I have to keep my restriction. So if it went this way, GH at X, and this is going to be a different answer, but this, because this right here, the H at X is the gluten-free, and if I knew I could keep my recipe gluten-free by plugging it in, that item in, that means I would be restricted. So this would have a domain of this if I worked it out. But it's so weird to kind of think about. So I give an analogy of a motor, but let's go a different route. There are vehicles that are gasoline engines, and there are vehicles that are diesel engines. I cannot put unleaded gas into a diesel engine. The engine will kind of run, and then it'll seize up because it fires too hot. Okay? You can't put diesel into a gasoline motor because diesel ignites based off combustion, not ignition. So those are both restricted. So that's kind of where you have to think. Hey, could I plug diesel into this and make it work? No, it's an ignition motor. You could try and ignite diesel all day long with a spark, and it's not going to go boom. If I smash it in a combustion type of situation, if there's no spark, that fuel is not going to ignite. If I combust, if I push together diesel fuel, so I go in a cylinder where I have a big volume, I squirt diesel in, and then I go, boom, I go like that. There's something called a glow plug, which is just makes it warm. Heat will introduce ignition. It'll boom, and allow the cylinder to go opposite way. And I know if you're not an auto mechanics, you're like, I don't know what the heck you're talking about. Just don't do this. The green nozzle, don't put it in your unleaded. Don't put the black nozzle into your diesel. It won't run. The diesel will indeed kind of run with the unleaded fuel in it, but the flip-flop won't. Okay? Now you're going to go home going, okay, he was talking about recipes and motors, and I thought we were in math. I don't know what the heck he's doing. Are we good with the front page? Everyone feel comfortable? Yeah.
So then what would the domain of
P of X. Just on the original problem?
Yeah.
Where's P of X? Oh, is that up on top?
Yeah, it's like 8x to the 4 thirds.
Okay, 4/3. So that means the third root. Third root, I can have negative numbers. So that would be negative to positive infinity.
So it's only restricted if
It's square root, or if my denominator is a 2, 4, 6, 8, if it's an even number. Even root means I can't make negative numbers come out of it. So if I had square root, or if I had fourth root, or I had sixth root, this would be, if this was just x plus 2, x plus 2, x plus 2, where these are all in the radical, this would say the domain would go from negative 2 to infinity. And that would be the same for all of those. Okay, because if I plugged anything less than negative 2 in, I would get a negative root. But if I had third root, fifth root, seventh root of x plus 2, or any of these, this would be negative to positive infinity. So you have to realize that these roots, this would be the same thing as saying x plus 2 to the 1/3 power, or the 1/5 power, or the 1/7 power. Okay? Cool. Did I answer your question? All right. Do we feel good with the first page? Happy? Content? Okay. Can I flip to the second page? Take a look at that. Good, honest look at that second page. Is there anything about that on that second page? 16 through 23 you would like to see worked out. $18. Yeah, buddy. Find the inverse function if it exists. If it does not exist, explain why. Okay. So number 18 is g at x equals x minus 3 quantity squared plus 5. Do you see any restriction on this problem, my friend? No, this is a parabola, agreed? This parabola will, being that I don't have any restrictions on the domain, will not have, and it's asking for the inverse function. So basically,
So don't we have to make one?
so this is going to look like that. The inverse relation would look something like this on the graphs. So this was not restricted at all. It doesn't pass the horizontal line test. So on the test next time, if I gave you this problem and there was nothing in the direction saying, hey, make this a restriction, you could say, does not exist, doesn't pass the horizontal line test. Okay, that is totally legit. Now, if I had the same problem, but I put a restriction to it, hang on, let's go with, okay. If I go, the domain of this, let's say they gave you this as 3 to infinity. Okay, that means you're talking about the positive component. Okay, that means my inverse has to have the positive component. So if I wanted to find this inverse, I'm going to get y equals x minus 3 quantity squared plus 5. I'm going to flip-flop my x and y. And then I'm going to solve for y. So I'm going to subtract 5. I'm going to take the square root of both sides. Now, normally the square root have plus or minus. This was the positive. Okay? It would be negative if it was going to negative infinity. So I'm only going to use this. So I have root x minus 5. I could put the plus there if I want. You don't need it. If you do, you're not wrong. And then you get this. And so then your answer is this. X minus 5 under the radical plus 3 outside of the radical restricted to that. Okay? And that tells you it'll work. Okay?
How do you know that the restriction is 3 again?
Actually, you don't even need this. The big thing is if they gave you this originally, you just need to note, hey, I'm using this because this graph right here looks just like this.
Yep.
It's missing this part down here. And so you don't even need, I wouldn't even worry about that. Okay? So this would be the inverse function of this function when I restricted it. But if it doesn't say anything about restriction, if it just gives you a parabola and it's not restricted, on the test you can say, does not exist, doesn't pass the vertical line test, or you can say something like, if I graph the inverse, the vertical line test won't pass, so it's not the inverse isn't a function. So those are just some funny words to kind of look at. If you get hung up on it, if I came over to look at your directions on that problem, I'd look saying, okay, it says find the inverse function if it exists. If it doesn't exist, explain why. Do you see a restriction there? You'd say no. I'd be okay. Then you'd have to say it would be a parabola. If I graphed it, I know a parabola is not going to work. If it was a parabola that was restricted, then we're fine. And the key word is inverse function. If it said find the inverse relation, a relation can be a sideways parabola. That's totally fine. It's just the special kind of relation called the function.
Would the inverse relation just be plus or minus in front?
Yeah, if it said find the inverse relation, you'd have this with a plus minus there, and that's it. Yeah. So you first?
22.
22, what'd you get?
23.
22 and 23? We'll take care of them both. All right, 22. 22 is the most complex problem you would see on the test. It's one of the easiest ones to work as soon as you realize what's taking place. Okay, it says, let f of x equal 6 minus 2x and have a domain of negative 3 to positive 3. Find the inverse. Okay, so I'm going to do this first. I'm going to flip out my x and y. I subtract 6. I'm going to divide both sides by negative 2. So I'm just going to make it like that. Is that okay? Now, they told me we have a domain of this. This is my domain that was given. So I'm going to go negative 3, plug it in, so I get 6 plus 6, so that's going to give me 12. I'll plug 3 in, 6 minus 3 is 0. So this is my range of my original. I plug my values in, put them in the correct order, because I want to go from least to greatest. So the range of this becomes the domain of this. Oops, square bracket. That's the domain. So because I do the flip-flop of the x and y, that means the domain and the range do a flip-flop. So you kind of have to say, okay, I have this domain, so I need to know I have to find the range. When I find the range of the original, this will transfer down to the domain of the inverse. And that means that the domain, that negative 3 to positive 3, becomes the range of the inverse as well. It probably won't ask for that, but just bonus footage. And you said 23? 23E. The one that says f prime of f of 5? Oh, you're not going to like me on this one. Ready? Letter E. F prime, or f to the negative 1 of f at 5. So all this means is I'm taking some function, I'm finding out what the x value would be if I plugged it in, and then I'm plugging that into the inverse. So if you see this terminology, that's my answer, and it's done. There's nothing more to do. So if this was f to the negative 1 of f smiley face, my answer is smiley face. So if you see that real quick, it's great. If you don't see it, you should do it this way.
Theoretically, you don't have to show any work.
No, I'd say you put an answer.
So then would F be X
Yeah. All right, no, the 5 is the x.
for F?
Oh, f. I'm sorry. Yes, that's just x. Yeah, like I would totally ignore the problem because, one, when you look at the problem, this is going to look like that kind of graph. My original. So it's already 1-to-1, so you know there's a inverse that's going to exist. I wouldn't even go through the fun events. I'd say, oh, you want f of the inverse. I want to plug the inverse back into the original, or if I want to plug the original back into the inverse, it's whatever it becomes. So that's just x. Okay? So yeah, E and F are the real fast ones. No work, answer only. And you know, this, my friends, I hate to say this, but this is kind of how the test is going to probably be set up. You have all these problems like here, and there's some room. And then we're going to have the f at f negative 1 of 7. And we're going to give you like an ungodly amount of space. And you're like, oh my gosh, I must have had a lot of work. Oh no, I'm just going to write a big 7 then. Okay? And I apologize in advance just how the spacing gets dorked up like that. And every time I give this kind of test, I can assure you, go to the one that has the biggest spacing. The biggest spacing we give you probably requires the least amount of work. The one that you have to write in 0.1 font and try and squeeze everything in, you're writing like Webster's dictionary in that little thing going, what the heck? Teacher doesn't even know how to space things out. I don't know why it happens. I swear, every time I give a test. Now, this is going to be different next time you see the test. You're going to be flipping through it and going, there's not one with big spacing. Well, maybe we got the spacing right this time. So, cool? Do we feel good with that second page? Any questions? Last page, 24 through 29. These are extraneous solutions, so let's make sure we understand the extraneous solution. Because if you say two things are your answer and one of them is supposed to be extraneous, that would take some points off. Yeah.
29.
29? 29, I would bet you is definitely going to have an extraneous solution. How do I know? Because I cheated a little bit. Actually, yesterday, Miss Schumann-Smith and I were talking about extraneous solutions, and she did this exact example we were talking about. And I just kind of remembered. All right, so what I'm going to do on this problem is I want to solve for x. So I have to square both sides first. Okay, x minus 2 equals x squared. Good so far? I'm going to move everything over. So 0 equals x squared minus x minus 2. We're good at factoring because my Algebra 1 teacher was really good at showing us it. Agree with that? Which means I have x minus 2 equals 0, x equals 2, x plus 1 equals 0, x equals negative 1. Okay, if I take 2 and plug it in, I get 2 minus 2 is 0. Square root of 0 is 0. Agreed? Is 0 equal to, x was 2? Is 0 equal to 2 this time? Did we just solve one of the great mysteries of math? No, 0 is not equal to 2. That's not one of the solutions. Let's see if negative 1 works. Negative 1 minus 2, negative 3. So I get square root of negative 3 equals negative 1. Is this one of the great mysteries of math? No solution. Or you could put like empty set or something like that. So that had two extraneous solutions. If I had graphed this graph is going to kind of look like this. Plus 2 looks like this. And the other one's going to look like this. So if I graphed them, they're never going to cross each other. Okay? What time we have here? 11? Time for anything quick? Feeling pretty? Yeah.
Can you just do one of the graph ones for
20. Sketch the inverse. Okay. Looks like I have negative 3, 2. 2. And I also have that point. So I have those 2 points. I have these 2 points that I can kind of look at my graph and definitely see. Okay? So this is the point, negative 2, 3. This is the point, negative 3, 2. So if I want to plot the inverse, that means I want to plot 3. Negative 2 is my starting point, so 3, negative 2 is my starting point. And 2, negative 3 is the next point. So 2, negative 3 is the next point. So this is going to kind of look like this. Something like that. 2, negative 3, 3. Yep. So all I did is I identified. You might want to try and see if you can get 3 points so you definitely know. But the best thing to do is you realize this is my starting point. So I'm going to graph 3, negative 2. So 3, negative 2, that's my starting point. This point are the starting point. And then just go from there. If you have something that looks like this, figure out what these points are. Figure out what those xy values are. And then plot y comma x. And then keep the order going. We happy? Content? Let's see, tomorrow is, or Thursday. Well, let's see. If you need to come by and see me, come by and see me. Today I have office hours still available 4th and 8th period. I'm also off 2nd period. If you wanted to see me on Thursday, I'd say come before school, but I think I have a math meeting on Thursday, and I apologize for that. Or if you're sitting at home going, can I do a Zoom call with me? Yeah, some evening, you have my number. Send me a text saying, hey, can we do a Zoom call? Just know this, I don't have my book at home with me, so I could do a Zoom call and I could talk you through it, but you better have your book with you to ask me what to do. Deal? You don't have my cell, do you? You got your cell right there? You're going to add my contact. Ready? Tell me when you're ready to start putting numbers in. 303 862 8. Oh, wait, no, I take it back. 720 720 273-8859. And I don't save your all numbers. If you text me, just when you text me, say, hey, it's me, Jennifer, from this class. That cool? Friends, get out of here. Have a great day. Take care of one another.